Okay, so now we're going to move on to another quadrilateral, and we're going to look at, first of all, finding the area of it, but something just to keep in the back of your head. You may have noticed, and you will notice by the end of this video, a certain type of trend, and that's the fact that a lot of the areas we have found have sort of depended on the area of other shapes that we found. For example, we noticed similarities between manipulating a parallelogram into a rectangle, and that allowed us to find out about the parallelogram's area. So, a lot of these ideas in maths, I want to put you in the position of being someone who is playing around with these different shapes and discovering the knowledge for yourself. Because when coming up with these formulas, a lot of it was done through playing around and trial and error and really just investigating these things. So I'm going to try to walk you through these types of thought experiments, and you'll see how knowing the area of one thing tells us a lot about the area of other things. And this is especially prevalent when we talk about the area of a trapezium. Now, the trapezium is a special type of quadrilateral. It's kind of like a bit of a weird one. As you can see from the poorly drawn one that I have here, the trapezium is a bit of an outcast in the quadrilateral family. It doesn't look as nice as a rectangle or a square. It also doesn't have nice features of a lot of different parallel sides where at least looks a bit coherent like a parallelogram or a rhombus. The trapezium itself only has one pair of parallel lines, these two here. But these are of different lengths. So when we join up with a couple more straight lines here, we get a kind of weird little crooked shape, so to speak. So this particular trapezium, we want to find the area of it. Now, to do this, let's just lay out, let's give these sides a name, for example. So I'm going to call this side A, and I'm going to call this side B. These don't need to mean anything. They're essentially just labels for a side. Now, we are looking at this trapezium now, and we don't know where to start. How could we even begin to find an expression for area here? We can't really, but let's have a look at another shape we've recently explored. So I'm going to get you to think back to the last video in which we looked at a parallelogram. Are there any similarities? Well, maybe not similarities, but can you think of maybe a way that we could make this trapezium into a parallelogram of sorts? Now, what if we were to say duplicate this trapezium? Now, that seems kind of weird, but let's just indulge me for a minute, and you may start to get some ideas, I'm hoping. But I'm going to draw this same trapezium, and I'm just going to flip it upside down. So it's going to look something like this. I'm going to have the longest side up here and the shorter side here. Now, these are still going to be parallel lines. Now, what if I were to shift this new parallelogram that I've drawn across so that it perfectly meets with this side? Let me draw this again. well, I've drawn it, but let me just rub it out and draw it connected to my original trapezium. So we have this here. We have the shorter side, and we're going to have, let me redraw that. And we're going to have the longer side here. Now, I'm going to relabel my sides. We have A and B up here. And these are still parallel. Now, because we flipped this and moved it across, our other sides here are still in the same orientation and they're straight lines. So these ones here are also going to be parallel. Now we have one pair of parallel lines and another pair of parallel lines. So by duplicating this trapezium, flipping it, reorientating it, gluing it together, so to speak, we now have a parallelogram, don't we? With a parallelogram with some perpendicular height, let's call it h. That's perpendicular, that's perpendicular. And our original trapezium, and we're just playing around here, and we're just noting observations. What portion of our entire shape does our original trapezium make up? Well, let me just shade it here. And we have two trapeziums, and I have just shaded in one of those. Now, thinking back to our fractions, the portion of the whole here, of our whole trapezium, of our whole parallelogram, sorry, so out of our entire parallelogram, one original trapezium makes up half of the entire area. So let me just note that down. So I'm going to write here, trap for trapezium is half the area of the parallelogram formed. Oh, didn't leave myself enough space. Now, this trapezium makes up half the area of the parallelogram. So we have a parallelogram and we can find its area, can't we? Because we just did in the last video. So the area of our parallelogram is just the base, well, these two base lengths, which are equal, multiplied by the perpendicular height. So we have an area of, so the area of the parallelogram, I'm just going to write this little subscript here, is our side A plus B multiplied by the perpendicular height, h. And that's our entire parallelogram, but our trapezium makes up half of that. So we can also take half lots of our area here, of our parallelogram. Or we can just take the area of the parallelogram, divide it by 2. Whether we multiply by half or divide by 2, it's the exact same thing. So we were able to uncover that the trapezium we had makes up half the area of a parallelogram when it's duplicated and flipped and joined together. So this is what I was talking about in the kind of preface at the start of this video, where we take what we know and we manipulate our shapes, take what we know about areas of other shapes, and that gives us some insight into what we were looking for originally. So we used what we know about the area of a parallelogram to give us some insight about the area of a trapezium. Now, I'll quickly change tabs here and I'll show you a similar thing just shown in GeoGebra, which I showed you for the parallelogram. So here we have it gives you the formula right off the bat, but all I'm going to do here is we have our original trapezium and I've duplicated it here. And this is essentially just a summary of what we've established here. So our original trapezium makes up half of the area of the parallelogram we've formed here. Now, I hope that made sense. Sorry if I waffled on a bit, but that is a more investigative way to try to find the area of a trapezium based on what we know about the parallelogram. See you next time.